Thank you so much for taking time to sit down with us today and talk a little bit more about your research grant on DOCK genes, novel risk alleles for cytokine storm syndrome, and a publication that you recently had published on a very similar topic. I'm really thrilled to hear the impact and progress of your work and excited to share it with the histiocytosis community. So thank you so much for your time today.
Yeah, happy to be here.
Fantastic. Well, Dr. Cron, for those who don't know you, I know that you are at the University of Alabama at Birmingham. Would you mind sharing a little bit about your role there and how you got into studying and treating histiocytosis?
I came here 17 years ago from the University of Pennsylvania, which is where I actually got my interest piqued in cytokine storm syndromes like HLH and MAS. And it was based on a patient that I saw with a colleague of mine. He was a fellow at the time, Ed Behrens, who's still at the University of Pennsylvania. But based on that patient interaction, I got really interested in kind of diagnosing these disorders, treating disorders, and then trying to explore the role of genetic contributions to these disorders. And that's kind of where this paper on specifically one gene, DOCK8, came out. There are pretty well established genes that lead to the familial or rare genetic form of these disorders that affect maybe 1 in 50,000 live births. And they're defects in genes that give rise to proteins, including perforin and other genes that are important for perforin to do what it does. Those are relatively straightforward now that we know which genes to look for. But the secondary forms of these disorders, of these cytokine storms that show up either later in childhood or in adults, don't have those homozygous or both chromosomes affected for those genes. Although, depending on which cohorts you look at that have been published, including some of our own, about 30 to 40% of patients will have single copy mutations or heterozygous mutations, and they can contribute to disease as well. It takes a lot of work to kind of demonstrate that because it's not as straightforward, but I think there's pretty good evidence that that's the case for some of these genes. However, there's another 50 or 60% in those cohorts where we don't have any known genetic contribution, and there may not be, but there may be. And so we've started exploring other potential genes that may contribute to these cytokine storms. And one of the ones that we kept seeing when we were doing kind of very broad screening of genes in these patients was this gene DOCK8. And we began to explore it because there had been data previously in individuals who were homozygous deficient in DOCK8, which can lead to a type of primary immunodeficiency, that their natural killer cells and their cytotoxic CD8 T cells were defective in their ability to kill. And that's very similar to what we see in cytokine storms, where they have difficulties in killing through this perforin pathway. So this paper that just came out was a collaborative effort of my lab here, and then actually Ed Behrens' lab and Scott Canna's lab at the University of Pennsylvania, where they model a lot of these diseases in mice. And so there's more exploration that can be done, obviously, in mice. You can manipulate them and study them in ways that we just can't do with patients, obviously. But the paper it's actually about 6 years in the working. And this poster behind me here was actually work that my son did when he was in high school working in my lab. And he's part of the manuscript as well, which is pretty cool. We had 3 patients that we had identified mutations in these DOCK8 genes. And we studied them in the lab and showed that they contributed actually to the inability, in this case, of natural killer cells, a type of these lymphocytes that can be defective, and showed that those individual mutations likely contributed to those individual patients' cytokine storms. And then Ed and Scott modeled this in mice that were completely deficient in DOCK8. Those mice had already been generated, but then they infected them with a virus that often triggers cytokine storms in mice that are deficient in perforin, for example, a virus called LCMV, and showed that, again, these mice get a cytokine storm syndrome-like problem when they're infected with these viruses, which kind of is analogous to what may happen in humans.
Wow, that's really interesting. And I know when you're thinking about discovering some of the drivers of a condition like HLH, it's exciting to discover new genes because there's likely a lot of things we still need to discover And this can only help in, I would assume, identifying patients that might be, predisposed to getting HLH, or when we get further down the line in newborn screening, something we could be looking for. Is that potentially some of the future implications of this work, or where could this lead us?
Yeah, I mean, so in the immediate term, there are companies, for example, who you can get clinical genetic data on your patients, some in a relatively timely fashion. And so one of my hopes is that DOCK8 will be included in their list of genes that they search for. There are other companies that do much broader searches, which DOCK8 is already included, so that's fine. But it's also important for people to know that amongst those several hundred genes, that DOCK8 is one that may be contributing. It's still tough because any individual mutation, we have to take it back to the lab and demonstrate it. So it doesn't always mean that even if you have a mutation in that gene that it contributed, but at least it gets people thinking about it. And then as part of the grant that we have with the Histiocytosis Association, we're also looking at a very similar gene, DOCK2, we started identifying also in other cytokine storm syndrome patients. And we're exploring that as well.
That's really interesting, and was really grateful that you made this sort of discovery and are looking into these further, because I think this is the first time that they're being looked at for HLH, and these are specifically for secondary HLH and MAS. So when thinking as well about adults that are diagnosed with HLH, is there possibility that this could be something that could be looked for in patients in the emergency room sometime in the future, when technology maybe catches up to what we're learning?
I hope so. I mean, and you bring up the issue of adults, that where I think the condition itself, the cytokine storm or the secondary HLH, it goes far underdiagnosed, because as pediatricians we're familiar with it, in large part because of the familial form of this disease that affects infants primarily. But because of that, we're aware of these disorders. On the adult side, not so much. And we're doing our best efforts to educate people on that. And I think it's starting to pay off. And we do see now publications of adult cohorts who have had cytokine storms like secondary HLH. And I do start seeing there are publications now where they're looking at the same genetics that we are and starting to see some of the same phenomenon of these even single copy mutations in these same genes that we at least know to look for at this point in time. So I think the message is getting there, and yet at some point, I don't know what kind of newborn screening there will be, because genetics has just gotten cheaper and cheaper. The analysis of it is still really the tricky part. And then even with the analysis, knowing if a single mutation contributes or not is also very hard to know. But, it'll just keep advancing.
Absolutely. It's exciting. So many different things are happening simultaneously that just give us a lot of hope for the future, that patients will be diagnosed a lot faster. And it also can help raise awareness, because if you aren't familiar with it, but it comes up in a test and you can find the information very easily, then the treatment can be administered, and it raises awareness about these, rare diseases like HLH and MAS. So it's really exciting. And we'll link the paper below for people to jump in and read more about it, as well as the link to the summary of the research grant that you're working on. Is there anything else you want people to be thinking about, or any other key points in the paper that you wanted to highlight as people might be taking a look through? We
included in the discussion similar work. Mostly from ourselves, but from other groups as well. So there is when COVID hit, many of these patients who were hospitalized at least were very sick and had features of a cytokine storm, not identical to a lot of what we're used to, but still enough features that, we had to treat the excess inflammation. Like steroids became an important treatment at a certain time point in the disease course when people were sick enough to be hospitalized. But as part of that, we did a very small clinical trial here in Birmingham, and a sub portion of that trial was actually looking at genetics. And we identified amongst 20 patients, very small numbers, 4 individuals who had DOCK8 mutations. And we've shown that some of those actually probably contributed to disease. And then there was this entity of multisystem inflammatory syndrome in children, or MISC, which occurred about a month after infection, so a kind of a post-infectious process that primarily affected children. We also found, in collaboration with Carolyn Fine-Levy and colleagues in New York, amongst 39 children that had MIS-C, 4 of them, so almost 10%, had mutations in DOCK8 as well that we also showed probably contributed to disease. And then there have been other groups around the world that have shown similar findings with DOCK8. So I think DOCK8 is showing up not just in our lab, but in multiple diseases and in different places around the planet as potentially a risk allele for some of these cytokine storms.
Wow, that's really interesting. Yeah, and to see it in various places and then be able to bring that into your work is also very validating that you're onto something really important and really being able to draw this parallel. So that's phenomenal. Thank you so much for the incredible work that you're doing. Is there a message that you want to share with the community in general about how either the work you're doing or where you see research headed for HLH or anything else about your paper that you want to just kind of share with the community?
I think just people believing the notion that DOCK8 and similar genes may be contributing factors, and they're not necessarily going to be as straightforward as having both copies, both chromosomes affected. But still, there's pretty good data, including some data from Claudio Garado on a gene called SDXBP2, which is one of the familial genes. But even having one bad copy can contribute to disease, and so just being aware of that and knowing the genetic risk factors, I think, will be important.
Absolutely, because you've shared with us your threshold model as well, which shows that having one copy and the right inflammatory situation can potentially push someone over that threshold as much as 2 bad copies, which is maybe something we also can include along with this if there's a way to link to it. But that's a very important point that you're making and really important for people to be thinking about.
Yeah, I think the threshold model, it may not be entirely correct, but at least it's a kind of like a format for us to think about having one bad copy and how, like exactly what you said, and you remembered it really well, is that you can have contributions that maybe partially decrease your NK cell or CD8 T cell function, and you're fine most of the time, but maybe you get a disease that's inflammatory like lupus or leukemia, and then you get an infection or something like Epstein-Barr virus on top of that, and it pushes your immune system to the point that it can no longer regulate itself. And that too much inflammation is what leads to the multi-organ system failure and all the horrible things that come with these cytokine storms.
That's a really important threshold, and I think something very I'm grateful that you've worked on it, that we can share it with the community, because I think it also really helps explain how HLH and other similar cytokine storm syndromes can manifest in the body, and gives us a better perspective on all the work that you're doing and the importance of it. So thank you so much for that, and I remembered it well because you explained it very well. Well, thank you so much for your time, Dr. Cron. I really appreciate everything that you're doing, and and with your lab and in partnership with other institutions and colleagues as well. Thank you for driving this initiative and this work, and we're really excited to share the publication and look forward to hearing more about what you learn as you continue in your research.
Yeah, it's been my pleasure. It's what drives me to come to work every day. It's really interesting stuff.